Earth has just been visited by the perfect solar storm.
The sun kicked up this just incredible solar flare and a massive amount of energy headed towards Earth.
Not only was this storm one of the two most powerful on record, it was also one of the fastest. Ejecting from a sunspot aimed directly at Earth, it raced from the sun to our planet in less than 18 hours.
Now it takes a really fast rocket ship years to get to the sun. This storm, this cloud of electrified particles, managed to get here in less than a day. That's incredibly fast.
Fortunately, the perfect solar storm took place in 1859, when the only technology vulnerable to the onslaught was the telegraph. Since the era in which we have become dependent on high technology, we've yet to see another perfect solar storm. The question remains, could it happen again?
What if we have another one like that? Can we have another perfect storm? Well, I'd say yes, we can. There's no doubt about that. The effects that would be on us today compared to 1859 could be devastating.
The effects on Earth and on our communication systems, we don't exactly know. That's the scary part.
It's likely that our modern technologies would be battered like beachfront houses during a hurricane. Imagine if we lost all the satellites that relay cell phone calls, television signals, and bank transactions. And what if, at the same time, the failure of power grids cascaded whole regions into darkness for hours or weeks? If these essential services couldn't be restored quickly, chaos wouldn't be far behind.
It would definitely be a ripple effect upon society and every man and woman and child that lives on this earth.
Solar storms can be as hard to predict as hurricanes. While forecasters lack the technology to foretell the next perfect storm, they do know that one would be more likely to hit at the peak of the sun's 11-year sunspot cycle.
What happens is the sun reverses the direction of its magnetic field every 11 years. So in 22 years, it reverses and comes back to where it was.
As we near the reversal every 11 years, the number of sunspots increases, and there's a spike in solar activity.
We call that period solar maximum. And those periods are interspersed about 5 years apart from periods we call solar minimum.
So you have this 11-year back and forth between the sun being sometimes very ferocious and it goes crazy and it's like the 4th of July with fireworks all the time. And then it starts to ramp down, and for a few years it gets quieter until we get to a low point where there's a firecracker now and then, but not a lot going on.
Just like hurricane seasons, solar maximums vary in intensity. Some produce many more powerful storms than others. Although we're currently at solar minimum, scientists are watching carefully to see what mayhem the next solar max might unleash.
So the last solar maximum was in about 2001, and so the next one ought to be about 2012. But there are different predictions. The whole field of solar physicists is basically waiting with bated breath to see what actually happens.
There are some wildly divergent opinions on what's going to happen. One group is suggesting that this next solar cycle could be the strongest in modern times.
If those predictions are correct, Earth could be in for a wild ride.
We might have to worry about a repeat of the 1859 event. If that were to happen today, it would wreak untold damage.
We're going to learn a whole lot about what can happen to modern technology when the sun blows its top.
Much of the violence in the sun erupts here, in the hellish outer atmosphere known as the corona. This region has long held one of the great solar mysteries, because even though it's 500,000 miles from the heat-generating core, it burns at millions of degrees. This seems to violate the very laws of physics.
That's very strange. I have a thermometer here. If I hold the thermometer close to the fire, it reads a very high reading. Where the probe is right now, it's over 200 degrees. Now, if I pull the probe out a little farther from the fire, okay, it drops down to about 90 degrees. Now, the farther I get from the center, the cooler it gets. In the atmosphere, the corona of the sun, the temperature soars as hot as the core. That's as if I were to say, well, way off behind me there, the heat from the fire is as hot as the fire itself, even though it's very far from the fire.
What force could possibly cause the superheating of the corona? The answer will rock you. The hellish solar corona rages at millions of degrees. For centuries, scientists have been baffled how anything so far from the sun's core could still burn so hot. Recently, as improved satellites offered a closer view of the solar surface, clues began to emerge. Below the corona, the sun's surface is literally boiling.
The reason is that the entire surface of the sun is covered with convection cells, hot material from the inside of the sun. It rises up through, reaches the surface, cools off by glowing, giving off sunlight, and then sinks back down. Each bubble of material that comes up is about the size of Texas. It spreads out across the surface, cools off, and sinks down in 5 minutes. So that's a tremendously violent process. Well, that's happening in literally almost 1 million places over the entire surface of the sun all the time, around the clock, 24/7.
This boiling isn't only violent, it's also extremely loud.
The sun is a tremendously loud place. If you could imagine covering the entire surface of the sun with speakers being driven as hard as the loudest rock concert you've ever been to, that would be comparable to how loud it really is on the surface of the sun.
The sun's churning surface creates enough sound energy to superheat the corona to millions of degrees. Scientists believe that a combination of these sound waves and energy from the sun's magnetic field is responsible for the extreme temperatures found in the corona.
Should we be worried about increasing solar activity? Michio Kaku is here with one of, well, he's obviously the professor. We all know him of theoretical physics. He's also the host of the sci-fi science show on the Science Channel, which is based on his book, Physics of the Impossible. Professor, should we be worried about these flare-ups? Or, you know, when talking about this morning, we all kind of agreed it has that Y2K feeling, like it could happen. But if it doesn't, we're going to spend a lot of money for nothing.
Well, we had a wake-up call just 2 weeks ago. Giant auroras, northern lights as far as Michigan and Wisconsin. And that's a warm-up for 2012-2013 when we hit the sunspot cycle. Every 11 years, the North Pole and the South Pole of the sun flip, releasing a burst of radiation. But Every 100 years or so, a monster tsunami from the sun emerges, which could literally cause trillions of dollars in property damage.
2012, that's a presidential election year. We need to keep that in mind. But if I'm walking around out there, as to whose fault it is, or at least the history, who they'll blame. So if I'm walking around, if I'm out sunbathing in a Speedo, will I look like Charles after about 5 minutes out there? Color, anyways. Obviously, I'm not going to look like Charles in a Speedo, but you know what I'm saying. I mean, is it going to really affect us like that?
It just went from bad to worse.
It could paralyze the economy of the planet Earth.
But not from a physical perspective.
Physical perspective, yeah. 1859, we had a gigantic solar storm which knocked out telegraph wires back then, 150 years ago. Yeah. If that had happened today, it would knock out almost all our satellites, knock out power stations. There would be food riots around the country because refrigeration would stop. Airplanes would probably crash without radar. It would paralyze the planet Earth. $2 trillion in property damage. And again, this is a once-in-a-century, once-in-2-century storm. The last one was 1859. But we do have them, and we have to worry about them.
That's a pretty high probability, once in 2 centuries.
Do we get a warning? I mean, is it like, hey, in 2 hours this happens, in 2 days this happens, in 2 weeks this happens? I mean, if the flare takes place, what kind of warning will we have to go to the other side of the Earth?
And who do you sue?
I'll figure that out. I got that.
Mark can tell you that later.
I got that covered, okay?
This is an act of God.
By the way, Michio, you might want to sign a waiver before you leave because Mark has you on his list already.
You have now put corporate America on notice. They are responsible for taking preparations. Go ahead, sir.
We have virtually no warning. It's like a giant earthquake. You can't predict giant earthquakes. They happen on a scale of once every 100, 200 years. That's what we have to worry about. We physicists have been telling Congress we have to reinforce our power stations. We have to have redundancy in our telecommunication systems, our satellites. Several of our satellites apparently have already been knocked out or at least disrupted because of solar flares. The space station has to worry about solar flares. But a giant one, like I said, could wipe out power stations on the Earth, wipe out communications, the internet, radar, airplane travel. It would be a mess. We'd be thrown back 100 years.
But are any steps being taken to, I mean, if God forbid this happens?
In Congress, there is a bill to pass a paltry $100 million. It's stalled in Congress right now. It's an insurance policy. It would cost very little to begin the process of reinforcing our transformers, power stations. And remember, this does happen even periodically. In 2003 in South Africa, 14 power stations were wiped out because a solar flare hit South Africa. In Canada, the city of Quebec was partially paralyzed, again, about 15 years ago because of a solar flare. These things happen, but the monster one is the one that we physicists are worried about.
Okay, before I get to you, we've got some breaking news here on mortgage rates. They're falling to their lowest level in decades. For the 8th time in 9 weeks, Freddie Mac says that the average 30-year fixed mortgage is now 4.42%. Wow. Before we let you go, Professor Kaku, how much would this cost to prevent, a guesstimate? Because the president is really enamored with scientists, a lot more than his predecessor. It seems that you can get the message through to the president. And do you think it will? Do you think you can, and how much will it cost us?
Well, you know, as part of the stimulus package, this would be chump change to give us $100 million.
$100 million, that's your number.
Just to reinforce power stations. Satellites will take more effort. We have to launch satellites that are reinforced to handle these things.
Do you have any connections with the White House personally?
Not personally, but
really?
Again, we physicists
I'm really surprised that you haven't been invited there. You're like one of the top science guys in the country. Maybe after the show. Listen, we're going to have to let you go. This is just, it's frightening stuff, but it's also things that we should be aware of. And coming from you, you add a lot of credibility to it.
All right.
Thanks a lot.